1. Avert mass poverty increase, feed 8 billion well. C9. Bottom line highlights. Breed crops that are more tolerant of drought and cold. Multi-crop land. Additional fertilization in Africa. Secure land ownership. Raise water, nutrient productivity, raise irrigation efficiency. Raise price on water. Move overprivileged down food chain. Limit to yield of aquifers and rivers. Produce protein more efficiently. Grain, then chicken, herbivorous fish, fish polyculture. Roughage for fodder. Fortified salt. Move poor up the food chain. Eradicate poverty. Stabilize climate. Low footprint transportation. Low footprint housing. Terminate food into fuel. China. A generation ago hundreds of millions of people were chronically hungry. Not only has China ended its dependence on food aid, but almost overnight it has become the world's third largest food aid donor. Hunger spreading. Sub-Saharan Africa and parts of the Indian subcontinent, the number of people in developing countries who are hungry has increased from a recent historical low of 800 million in 1996 to 830 million in 2003. Record or near record grain prices in late 2007 will likely raise the number of hungry people even further, with children suffering the most. Threefold expansion in the world grain harvest since 1950. Rapid adoption in developing countries of high-yielding wheats and rices originally developed in Japan and hybrid corn from the United States. Tripling of irrigated area and an 11-fold increase in world fertilizer use. Tripled the world grain harvest. Growth in irrigation and fertilizer use essentially removed soil moisture and nutrient constraints on much of the world's cropland. Outlook is changing, terrifyingly. Farmers are faced with shrinking supplies of irrigation water, diminishing response to additional fertilizer use, rising temperatures, the loss of cropland to non-farm uses, rising fuel costs, and a dwindling backlog of yield-raising technologies, annual addition of some 70 million people a year, desire of some 5 billion people to consume more livestock products. Millions of motorists turning to crop-based fuels to supplement tightening supplies of gasoline and diesel fuel. This helps explain why world grain production has fallen short of consumption in 7 of the last 8 years, dropping world grain stocks to the lowest level since 1974. Farmers and agronomists are now being thoroughly challenged. Rethinking land productivity. Between 1950 and 1990, world grain yield per hectare climbed by 2.1% a year. From 1990 to 2007, however, it rose only 1.2% annually. The yield response to the additional application of fertilizer is diminishing, and partly because irrigation water supplies are limited. Breed crops that are more tolerant of drought and cold. US corn breeders have developed corn varieties that are more drought tolerant, enabling corn production to move westward into Kansas, Nebraska, and South Dakota. Kansas, the leading US wheat producing state, has used a combination of drought-resistant varieties in some areas and irrigation in others to expand corn planting to where the state now produces more corn than wheat. Similarly, corn production is expanding in more northern states such as North Dakota and Minnesota. Multi-cropped land, where soil moisture permits, is to increase the area of multi-cropped land that produces more than one crop per year. The tripling in the world grain harvest since 1950 is due in part to impressive increases in multiple cropping in Asia. A concerted US effort to both breed earlier maturing varieties and develop cultural practices that would facilitate multiple cropping could substantially boost crop output. Western Europe, with its mild winters and high-yielding winter wheat, might also be able to double crop more with a summer grain, such as corn, or with a winter oilseed crop. Elsewhere, Brazil and Argentina have an extended frost-free growing season that supports extensive multicropping, often wheat or corn with soybeans. Africa. There are still some places, However, such as most of Africa, where additional fertilizer would help boost yields. Encouraging response to this situation in Africa is the simultaneous planting of grain and leguminous trees. Has enabled farmers to double their grain yields within a matter of years as soil fertility builds. Secure land ownership. Secure land ownership encourages farmers to invest in and improve their land. A Rural Development Institute survey in China revealed that farmers with documentation of land rights were twice as likely to make long-term investments in their land, such as adding greenhouses, orchards, or fish ponds. Despite local advances, the overall loss of momentum in expanding food production is unmistakable. Will force us to think more seriously about stabilizing population, moving down the food chain, and using the existing harvest more productively. Achieving an acceptable worldwide balance between food and people may now depend on stabilizing population as soon as possible, reducing the unhealthily high consumption of animal products among the affluent, and restricting the conversion of food crops to automotive fuels. Raising water productivity. World needs an effort to raise water productivity similar to the one that nearly tripled land productivity during the last half of the 20th century. Land productivity is typically measured in tons of grain per hectare or bushels per acre. A comparable indicator for irrigation water is kilograms of grain produced per ton of water. Worldwide, that average is now roughly 1 kilogram of grain per ton of water used. Water productivity. It takes 1,000 tons of water to produce 1 ton of grain. 70% of world water use is devoted to irrigation. Raising irrigation efficiency is central to raising water productivity overall. Using more water efficient irrigation technologies and shifting to crops that use less water. Eliminating water and energy subsidies that encourage wasteful water use allows water prices to rise to market levels. Local rural water users associations that directly involve those using the water in its management have raised water productivity in many countries. Irrigation water efficiency. Usage of irrigation water never reaches 100% simply because some irrigation water evaporates, some percolates downward, and some runs off. Irrigation efficiency ranges between 25 and 40% in India, Mexico, Pakistan, the Philippines, and Thailand, between 40 and 45% in Malaysia and Morocco, and between 50 and 60% in Israel, Japan, and Taiwan. Irrigation efficiency. Irrigation water efficiency is affected not only by the type and condition of irrigation systems, but also by soil type, temperature, and humidity. In hot arid regions, the evaporation of irrigation water is far higher than in cooler, humid regions. China plans to raise China's irrigation efficiency from 43% in 2000 to 51% in 2010, and then to 55% in 2030. By raising the price of water, providing incentives for adopting more irrigation efficient technologies, and developing the local institutions to manage this process. Raising irrigation efficiency. Shifting from the less efficient flood or furrow system to overhead sprinklers or drip irrigation, the gold standard of irrigation efficiency. Switching from flood or furrow to low pressure sprinkler systems reduces water use by an estimated 30%, while switching to drip irrigation typically cuts water use in half. Drip systems are both labor intensive and water efficient. They are well suited to countries with a surplus of labor and a shortage of water. Drip irrigation. Cyprus, Israel, and Jordan rely heavily on drip irrigation. Used on 1-3% of irrigated land in India and China, and on roughly 4% in the United States. Has the potential to profitably irrigate 10 million hectares of India's cropland, or nearly 1/10 of the total. Similar potential for China. Punjab, with its extensive double cropping of wheat and rice, fast falling water tables led the State Farmers Commission in 2007 to recommend a delay in transplanting rice from May to late June or early July. This would reduce irrigation water use by roughly 1/3 since transplanting would coincide with the arrival of the monsoon. This reduction in groundwater use would help stabilize the water table, which has fallen from 5 meters below the surface to 30 meters in parts of the state. Mexico Developing Water Users Associations. 2002, farmers associations managed more than 80% of Mexico's publicly irrigated land. Associations often need to charge more for irrigation water, but for farmers, the production gains from managing their water supply themselves more than outweigh this additional outlay. Tunisia, where water users associations manage both irrigation and residential water, the number of associations increased from 340 in 1987 to 2,575 in 1999, covering much of the country. Many other countries now have such bodies managing their water resources. Although the early groups were organized to deal with large publicly developed irrigation systems, some recent ones have been formed to manage local groundwater irrigation as well. Their goal is to stabilize the water table, to avoid aquifer depletion and the economic disruption that it brings to the community. Low water productivity is often the result of low water prices. Subsidies lead to irrationally low water prices, creating the impression that water is abundant when in fact it is scarce. As water becomes scarce, it needs to be priced accordingly. Northern China is raising water prices in small increments to discourage waste. Higher water price affects all water users, encouraging investment in more water-efficient irrigation technologies, industrial processes, and household appliances. Needed now is a new mindset, a new way of thinking about water use. For example, shifting to more water-efficient crops, wherever possible boosts water productivity. Rice production is being phased out around Beijing, because rice is such a thirsty crop. Similarly, Egypt restricts rice production in favor of wheat. Any measures that raise crop yields on irrigated land also raise the productivity of irrigation water. Similarly, any measures that convert grain into animal protein more efficiently in effect increase water productivity. Moving down the food chain reduces water use. In the United States, where annual consumption of grain as food and feed averages some 800 kilograms, 4/5 of a ton, per US person, a modest reduction in the consumption of meat, milk, and eggs could easily cut grain use per person by 100 kilograms. For 300 million Americans, such a reduction would cut grain use by 30 million tons, and would cut irrigation water use by 30 billion tons. Reducing water use to the sustainable yield of aquifers and rivers worldwide involves a wide range of measures not only in agriculture, but throughout the economy. More water-efficient industrial processes, and using more water-efficient household appliances. Recycling urban water supplies is another obvious step to consider in countries facing acute water shortages. Producing protein more efficiently, another way to raise both land and water productivity. Some 37%, about 740 million tons, of the world grain harvest used to produce animal protein. Even a modest gain in efficiency can save a large quantity of grain. World meat consumption increased from 44 million tons in 1950 to 240 million tons in 2005, more than 5 times, more than doubling consumption per person from 17 kilograms to 39 kilograms, 86 pounds. In every society where incomes have risen, meat consumption has too. Nature's production of fish and beef has leveled off, as both the oceanic fish catch and the production of beef on rangelands have leveled off. The world has shifted to grain-based production of animal protein to expand output. And as the demand for meat climbs, consumers are shifting from beef and pork to poultry and fish, sources that convert grain into protein most efficiently. Health concerns among industrial country consumers are reinforcing this shift. Animals' conversion of grain into protein varies widely. With cattle in feedlots, it takes roughly 7 kilograms of grain to produce a 1 kilogram gain. In live weight 250% less efficient. For pork, the figure is over 3 kilograms of grain per kilogram of weight gain, 50% less efficient. For poultry it is just over 2, and for herbivorous species of farmed fish, such as carp, tilapia, and catfish, it is less than 2. Animal protein production trends. Global beef production, most of which comes from rangelands, grew less than 1% a year from 1990 to 2006. Growth in the number of cattle feedlots was minimal. Pork production grew by 2.6% annually, and poultry by nearly 5%. The rapid growth in poultry production, going from 41 million tons in 1990 to 83 million tons in 2006, more than double, enabled poultry to eclipse beef in 1995, moving it into second place behind pork. World pork production, half of it now in China, overtook beef production in 1979, and has continued to widen the lead since then. Highly grain-efficient fish farm output may also overtake beef production within the next decade or so. Herbivorous fish convert feed into protein so efficiently. Aquacultural output expanded from 13 million tons in 1990 to 48 million tons in 2005, growing by more than 9% a year, 3.7 times. Salmon, shrimp, environmentally inefficient or disruptive. Salmon, a carnivorous species, and shrimp. These operations account for 4.7 million tons of output, less than 10% of the global farmed fish total, but they are growing fast. Salmon are inefficient, in that they are fed other fish, usually as fish meal, which comes either from fish processing wastes, or from low-value fish caught specifically for this purpose. Shrimp farming often involves the destruction of coastal mangrove forests to create areas for the shrimp. Herbivorous fish. Worldwide, aquaculture is dominated by herbivorous species, mainly carp in China and India, but also catfish in the United States and tilapia in several countries and shellfish. This is where the great growth potential for efficient animal protein production lies. China, world's leading producer, accounts for an astounding 2/3 of global fish farm output. Dominated by finfish, mostly carp, which are produced inland in freshwater ponds, lakes, reservoirs, and rice paddies, and by shellfish, mostly oysters, clams, and mussels, which are produced mostly in coastal regions. China has also developed a fish polyculture, using 4 types of carp that feed at different levels of the food chain, in effect emulating natural aquatic ecosystems. Silver carp and bighead carp are filter feeders, eating phytoplankton and zooplankton respectively. The grass carp, as its name implies, feeds largely on vegetation, while the common carp is a bottom feeder, living on detritus. These 4 species thus form a small ecosystem, with each filling a particular niche. This multi-species system, which converts feed into high-quality protein with remarkable efficiency, allowed China to produce some 14 million tons of carp in 2005. Aquacultural output in China at 30 million tons is double that of poultry, making it the first major country where fish farming has eclipsed poultry farming. China aquaculture. China's aquaculture is often integrated with agriculture, enabling farmers to use agricultural wastes, such as pig or duck manure, to fertilize ponds, thus stimulating the growth of plankton on which the fish feed. Fish polyculture, which commonly boosts pond productivity over that of monocultures by at 50%, is widely practiced in both China and India. Other countries following: Thailand and Vietnam. Vietnam, for example, devised a plan in 2001 of developing 700,000 hectares of land in the Mekong Delta for aquaculture, which now produces more than 1 million tons of fish and shrimp. In the United States, catfish, which require less than 2 kilograms of feed per kilogram of live weight, is the leading aquacultural product. US annual catfish production of 600 million pounds, about 2 pounds per person, is concentrated in the South. Mississippi, with easily 60% of US output, is the catfish capital of the world. Soy indirectly consumed. When we think of soybeans in our daily diet, it is typically as tofu, veggie burgers, or other meat substitutes. But most of the world's fast-growing soybean harvest is consumed indirectly in the beef, pork, poultry, milk, eggs, and farmed fish that we eat. Although not a visible part of our diets, the incorporation of soybean meal into feed rations has revolutionized the world feed industry, greatly increasing the efficiency with which grain is converted into animal protein. Soybeans. In 2007, the world's farmers produced 222 million tons of soybeans, 1 ton for every 9 tons of grain produced. Of this, some 20 million tons, 10%, were consumed directly as tofu or meat substitutes. The bulk of the remaining 202 million tons, after some was saved for seed, was crushed in order to extract 37 million tons of soybean oil, separating it from the highly valued, high-protein meal. The 160 million or so tons of protein-rich soybean meal that remain after the oil is extracted is fed to cattle, pigs, chicken, and fish. Combining soybean meal with grain in roughly on a per meal to 4 parts grain dramatically boosts the efficiency with which grain is converted into animal protein, sometimes nearly doubling it. Explains why world soybean production has increased nearly 14-fold since 1950. Roughage rather than grain. Mounting pressures on land and water resources have led to an evolution. Since 1970, India's milk production has increased more than 4-fold, jumping from 21 million to 96 million tons. 1997, India overtook the United States to become the world's leading producer of milk and other dairy products. 1965, National Dairy Development Board. Purpose was to market the milk from tiny herds. Creating the market for milk spurred the 4-fold growth in output. India has built the world's largest dairy industry almost entirely on roughage wheat straw, rice straw, corn stalks, and grass gathered from the roadside. Even so, the value of the milk produced each year now exceeds that of the rice harvest. Second harvest from the original grain crop. A second new protein production model, one that also relies on ruminants and roughage, has evolved in 4 provinces in eastern China: Hebei, Shandong, Henan. Although wheat straw and corn stalks are often used as fuel for cooking, villagers are shifting to other sources of energy for this, which lets them feed the straw and corn stalks to cattle. Supplementing this roughage with small amounts of nitrogen in the form of urea allows the microflora in the complex 4-stomach digestive system of cattle to convert roughage into animal protein more efficiently. These 4 crop-producing provinces in China, dubbed the Beef Belt by officials, use crop residues to produce much more beef than the vast grazing provinces in the northwest do. The use of crop residues to produce milk in India and beef in China lets farmers reap a second harvest from the original grain crop, thus boosting both land and water productivity. World desperately needs more new protein production techniques. Meat consumption is growing 2 times as fast as population. Egg consumption is growing nearly 3 times as fast, and growth in the demand for fish both from the oceans and from fish farms is also outpacing that of population. A massive new threat. The world has had many years of experience in feeding an additional 70 million people each year. It has no experience with some 5 billion people striving to move up the food chain at the same time. Diversifying diets has dramatically improved nutrition in China. Half the women in the developing world suffer from anemia, the world's most common nutritional deficiency. Diets high in starchy food and low in iron-rich foods, such as leafy green vegetables, shellfish, nuts, and red meat lead to insufficient iron in the diet, which in turn leads to low birth weights and high infant and maternal mortality. Eliminating anemia. Encouragingly, a decade of research by the Canadian-based Micronutrient Initiative has succeeded in fortifying salt with iodine and iron together. Just as iodine fortification of salt eliminated iodine deficiency diseases, so too can the addition of iron eliminate iron deficiency diseases. This double fortified salt is being introduced initially in India, Kenya, and Nigeria. The prospect of eliminating iron deficiency disorders at an annual cost of 20 C per person is one of the most exciting new options for improving the human condition in this new century. Moving down the food chain. A. At what level of food consumption? One of the questions I'm most often asked is, Q. How many people can the earth support? At the US level of 800 kilograms of grain per person annually for food and feed, the 2 billion ton annual world harvest of grain would support 2.5 billion people. At the Italian level of consumption of close to 400 kilograms, the current harvest would support 5 billion people, 100% more. At the 200 kilograms of grain consumed by the average Indian, it would support a population of 10 billion, 300% more. More income, up the food chain. In every society where incomes rise, people move up the food chain, eating more animal protein as beef, pork, poultry, milk, eggs, and seafood. The mix of animal products varies with geography and culture, but the shift to more livestock products as purchasing power increases appears to be universal. As consumption of livestock products, poultry, and farmed fish rises, grain use per person also rises. Ends of the spectrum. Roughly 800 kilograms of grain consumed per person each year in the United States. About 100 kilograms is eaten directly as bread, pasta, and breakfast cereals. 700 kilograms. The bulk of the grain is consumed indirectly in the form of livestock and poultry products. By contrast, in India, where people consume just under 200 kilograms of grain per year, or roughly a pound per day, nearly all grain is eaten directly to satisfy basic food energy needs. Little is available for conversion into livestock products. Life expectancy. Life expectancy is highest in Italy, even though US medical expenditures per person are much higher. People who live very low or very high on the food chain do not live as long as those in an intermediate position. Mediterranean type diet that includes meat, cheese, and seafood, healthier and live longer. High on the food chain, such as Americans or Canadians, can improve their health by moving down the food chain. In low-income countries like India, where a starchy staple such as rice can supply 60% or more of total caloric intake, eating more protein-rich foods can improve health and raise life expectancy. What we eat affects climate. Energy used in the food economy to provide the typical American diet and that used for personal transportation are roughly the same. The range between the more and less carbon-intensive transportation options and dietary options is each about 4 to 1. With cars, the Toyota Prius, a gas-electric hybrid, uses scarcely 1/4 as much fuel as the Chevrolet Suburban SUV. Similarly with diets, a plant-based diet requires roughly 1/4 as much energy as a diet rich in red meat. Shifting from a diet rich in red meat to a plant-based diet cuts greenhouse gas emissions as much as shifting from a Suburban SUV to a Prius. Reduce the demand for land, water, and fertilizer. Stabilize climate. Inclusion of soybean meal in feed rations to convert grain into animal protein more efficiently. The shift by consumers to more grain-efficient forms of animal protein, and the movement of consumers down the food chain. This reduces carbon emissions, and thus helps to stabilize climate as well. Action on many fronts. October 2007, the food prospect does not look particularly promising. Grain prices in recent days have reached historic highs. Wheat has gone over $9 a bushel for the first time in history, more than double the figure a year earlier. International food aid flows are being slashed as rising grain prices collide with fixed budgets. If we continue with business as usual, the number of hungry people will soar. Cheap food may now be history. Ensuring adequate supplies of grain was a simple matter. Whenever the world grain harvest fell short and prices started to rise, the US Department of Agriculture would return to production the cropland that had been idled under commodity supply management programs, thus boosting output and stabilizing prices. This era ended in 1996, when the United States discontinued its annual cropland set-aside program. Eradicating hunger depends on eradicating poverty. Hunger is almost always the result of poverty. Where populations are outrunning their land and water resources, eradicating hunger also depends on stabilizing population. Our Plan B goal is to stabilize world population by 2040 at the 8 billion level. This will not be easy, but the alternative may be a halt in population growth because of rising mortality. energy may have a greater influence on future food security. New reality is that the Ministry of Energy may have a greater influence on future food security than the Ministry of Agriculture. Principal threat to food security today is climate change from the burning of fossil fuels. Minimize crop withering heat waves. Prevent the melting of the glaciers that feed Asia's major rivers during the dry season. To prevent the ice sheet melting that would inundate the river deltas and floodplains that produce much of the Asian rice harvest. A world where cropland is scarce. Whether to develop auto-centered systems or more diversified transport systems that are less land intensive, including light rail, buses, and bicycles, will directly affect world food security. Transportation policies that diversify transport systems and reduce fossil fuel use will also help stabilize climate. Crop-based automotive fuels. Given the turmoil in world grain markets in late 2007, it is time for the US government to place a moratorium on the licensing of any more grain-based ethanol distilleries. We have a role to play as individuals. Whether we bike or drive to work will affect carbon emissions, climate change, and food security. The size of the car we drive to the supermarket may affect the size of the bill at the supermarket checkout counter. If we are living high on the food chain, we can move down, improving our health while helping to stabilize climate. Food security is something in which we all have a stake and a responsibility. Bottom line highlights. Breed crops that are more tolerant of drought and cold. Multi-crop land. Additional fertilization in Africa. Secure land ownership. Raise water, nutrient productivity, raise irrigation efficiency. Raise price on water. Move overprivileged down food chain. Limit to yield of aquifers and rivers. Produce protein more efficiently. Grain, then chicken, herbivorous fish, fish polyculture. Roughage for fodder. Fortified salt. Move poor up the food chain. Eradicate poverty. Stabilize climate. Low footprint transportation. Low footprint housing. Terminate food into fuel.